Happy New Year's to everybody, and welcome to section 4.2. We're talking about polynomials today. Now, what is a polynomial? As the name suggests, poly means many, and nomial means terms, so there's many terms. Now, there's a few conditions with a polynomial, okay? So it's in this general form where you have a base and an exponent, but there can be multiple terms, and we'll get in that a little bit, but there could be something like this, and then plus a number with apparently no exponent. Okay, but we're just talking about what are the requirements of the exponent in the base. So the base, a in this case, must be a real number. Okay, and I'm just going to abbreviate. I'm going to change it to blue actually. So it's got to be a real number. That means it can be a decimal, it can be a fraction. It just can't be an imaginary number. Okay. Like the negative, a square root of a negative 16, for example. Now, n must be a whole number for this. Okay, so this must be a, hold on, working on writing it. It must be a whole, I think my pen, there we go. It must be a must be a whole number. There we go, finally. Little pen difficulties. So it's got to be a whole number. That means it can't be negatives. It can't be fractions for the exponent. Okay. The base can be anything. It has to be real. So some examples of non-polynomials. Let's talk about those. So some non-polynomials. Well, a has to be real. Okay, we'll talk about that. But let's mostly focus on n. What can n not be? For example, the square root of a plus 2. Okay, the reason why this does not match is because that means the exponent is going to be a fraction, and it has to be a whole number. So that's breaking one of the conditions. And then another one, a non-polynomial is something like this, where you have x squareds or x terms in the denominator. The reason why it breaks that rule is because that's a negative exponent. This could be rewritten as x squared plus x to the negative first power. So you can't have a negative exponent. That's why that is a non-polynomial. Now, when we're talking about polynomials, we have the different terms here, and then the coefficients are the numbers being multiplied. Okay, think of these as the numbers in front of the variables. Okay, and then for the degree, this is the highest exponent in the polynomial. So here, what is the coefficients of this first 12x to the 9th power? Well, the coefficient is 12. It's 12 times the variable. And the degree is 9. That's the highest power in this one. Okay, there's no other term, so it's easy to identify the highest power. Technically, this 12 is to the first power, but we don't really count it. We just consider it a coefficient. Next one, we have 3x. So the coefficient is 3. And the power is actually 1. It looks like, oh, you might think it's 0. No. Anytime it's just the variable, it's an implied 1 for the degree. Now here we have negative 6. Now you're probably thinking, okay, there's no variable, so how can there be a coefficient? Well, there's always a coefficient because there's technically always a variable. Now you're thinking, oh, you just wrote an x in there. You can't do that. Well, I can make it x to the 0 power. X to the 0 power is the same thing as 1. Negative 6 times 1 is just negative 6. So technically that's legal. So my degree here would be 0. Anytime you don't see a variable, technically there is a variable. It's just to the 0 power. And then here our coefficient. This one's a little trickier because we could rewrite this as 1/3 x squared. So in this case it's 1 over 3 is our coefficient and our degree is 2. So that's just an example of how to get acclimated to the coefficients and degrees of polynomials. Now there's three main different types of polynomials. We have monomials, and that means one term. So all the ones we just did were monomials. And I'm going to go pink for this one. So a monomial, for example, could be negative 3x to the 3rd power. That would be a 3rd degree. And we could have 4. That could be a monomial, and that would be degree of 0. So those are two monomials. Let's go ahead and jump to a different color. Let's go orange. So then we have binomial. So all of these have the same kind of root process. So mono meaning one, bi meaning two, meal meaning terms. So we have two terms now. One of our examples we could have 4x squared. If I can write this a little more clearly, 4x squared plus 2. That would be a binomial because there's two terms, and the highest degree would be 2 here. Or we get something like negative x to the 5th power minus 3x. I'm just coming up with this right on the spot. 3x to the 4th. And that would be a 5th degree binomial, two terms. Okay, as you might expect, the last one we're going to do today is trinomials. And obviously they can have more than just 3 terms, but these are the most popular ones. So trinomial, popular trinomial, we could have x squared plus x plus 1. I wanted to change the color, but oh well. This color doesn't match. Here, watch me make this match. Style. Now it matches. How about that? There's a popular trinomial. We could also have something like x to the, let's go 4th power plus 3x third minus 15x squared. And this would be a 4th degree. I forgot to write this one. This would be a 2nd degree. Notice how whenever you write these polynomials, you always want to have it in descending order. What does that mean? That means the power should go from biggest on the left. Okay, the power should go biggest on the left to the smallest on the right. So if it doesn't have a power, then that's going to be all the way to the right. No x means all the way to the right. Even if the coefficient's really big, it doesn't matter. You're only going based on the variable and the exponent. Okay, so now that you know about polynomials, let's do an example where we're combining them. So here we have just negative, we have two sets of parentheses here, negative 6m squared minus 8m plus 5 minus a negative 5m squared plus 7m minus 8. The first thing I always do when I have these types of problems with parentheses is I want to get rid of the parentheses. And usually that means that we have to distribute something. In this case, I'm going to distribute this negative to all 3 terms over there. I can simply get rid of the parentheses on the left because there's nothing to distribute. As you can see there, nothing to distribute. Now, after I distribute the negative to the negative, it means positive 5m squared, negative 7m, and positive 8. Once I get to this point, what I like to do is I like to underline the like terms. So here I have an m squared, and I'm looking for the same degree here. Okay, when you combine like terms, really what you're looking for, combine like terms, really what that means is to combine the same degree. So all of these are different monomials pieced together into a giant polynomial, but we're trying to simplify this. So we're going to find the same degree. So here's the same degree. I'm going to use a different kind of line this time. So you can see negative 8m, negative 7m, and then we have our constants. I'm going to use one line for the constant. It doesn't matter. I just like to differentiate between my different terms. And sometimes I'll use color, but if you're just using a pencil and paper, you won't be able to do color, so I like doing different styles of line. So I have negative 6m squared plus 5m squared. That gives me negative 1m squared. I don't need the 1 there. I can just have it be negative, but I just want to show you my thought process. So I have negative 15. I'm doing the m's next. I'm going in descending order of the powers. So I have negative 15m, and then I'm doing my constants, which is plus 13. And I have nothing left there. I combined all the terms that there were to combine. So I am done with all my work. That's all there is for polynomials with this introduction. I hope you got something out of this video, and I look forward to seeing you in 4.3. We're talking about polynomial functions, so stay tuned for that, and Happy New Year again.